In our lab activity yesterday, we discovered how electricity could be used to make a magnetic field. Today we're going to be finding out how these electromagnets work. We're still looking at our state standard that says that forces between objects can act when they are touching and when they are not touching. So electromagnetism would be another example of a field force. Our I can statement today is that I can explain the relationship between electricity and magnetism using electromagnets. So electromagnetism is just this relationship between electricity and magnetism. When you run an electric current through coils of wire, you produce an electric field. We did this yesterday with the coils of wire around the nail, and then we hooked that to the battery. We made that nail magnetic for a short period of time while it was hooked to the battery. Down in this comic, we have a hockey game, and just like any good professional hockey game, there are fights. So it says to help refs during hockey melees, NHL teams must now wear electromagnetic jerseys of the same polarity. So here we have the referee. He has the on switch, and we have the opposite teams going against each other. Now, what's interesting is they need jerseys of the same polarity because, as we know with magnets, when they are the same, they repel. So because this is an electromagnet, they can play the hockey game as normal. And when the fighting occurs, we switch on the electromagnet. Their shirts all become the same polarity, and now no one can get near each other to fight because that magnetic field in the shirt has basically bumped into the magnetic field of the other team's jersey, and they can't get near each other to fight. Electromagnetic induction. This is where we have a wire that we just move through a magnetic field, and it will actually cause the electrons to move through the wire. So we can create electricity by moving the wire in a magnetic field. This is one way to produce a generator where you're actually creating electricity. Generators can also be used to convert mechanical energy to electrical energy. So if we were to put a magnet inside another magnetic field and switching the polarities of that magnet, we can cause it to continually spin. It'll be pulled towards the side that it is not like, and it will be repelled by the side that it is the same as. And as it does that, it will create an electric current that can flow through the wire. So again, these are generators. We are generating or creating electricity, making the electrons flow through the wire. Now yesterday, around our nail, we created what's called a solenoid. We created a coil of wire, and we passed an electric current through that wire, and when that happened, we made our nail become a bar magnet. The paper clips were able to stick to it. So again, we created an electromagnet, which acts like a bar magnet when there is an electric current running through it. Now, an electromagnet is temporary, meaning it can be turned on and off. We create this by wrapping wire around some type of strong core. Usually this is going to be something that has iron in it. The core has to be something that is attracted to a magnet.
We now know that we can generate current using magnetic fields, but we can also generate magnetic fields using current. How does this happen? As current is passed through a wire, it creates a magnetic field. Where this gets interesting is when we put a loop or turn in. By simply adding more loops to the coil, we can generate a more concentrated magnetic field inside the coil without having to adjust the current. This is what is known as an electromagnet. The field can also be increased by adding more current or decreasing the radius of the loop. Likewise, the field can be decreased by lowering the current and increasing the radius. These electromagnets have the same properties as permanent magnets. They both have north and south poles, but the difference is that we can control the magnetic field. This affords us some interesting opportunities.
To make sure we understand magnetic fields, we need to understand the characteristics of them. They are different than permanent magnets because they can be controlled by turning them on and off. Also, we can reverse the direction of the current, which will actually reverse which pole is north and south on the magnet. Also, we found out yesterday in our lab activity that if we add the loops or coils of wire around that magnetic core, it will create a stronger magnetic field. So again, to increase the strength of the magnetic field, we have a couple things we can do. One, we increase the current. We add more power to it, and that will increase the strength of our electromagnet. We also, like we said, found out yesterday, we add more loops to the wire. We have a stronger electromagnetic field. If we put those loops closer together, so here in the top we have 3 loops and they're widely spaced, then we have 3 loops that are closely spaced. The closer they are, the stronger that force is going to be. Also, if you put a stronger material in as the magnetic core, the ferromagnetic core, it will have a stronger magnetic field, electromagnetic field. Now, motors are something that takes electrical energy and turns it into mechanical energy, again, by using something spinning. We're using the magnets to create motion, something to maybe drive the fan blades, to turn wheels in a car, those kinds of things if you're using an electric motor. So over here in the picture, you can see that the current comes in, causes the electromagnet to rotate inside where this permanent magnet is, and that constant motion of that rotating electromagnet will cause the axle that's attached to it to spin as that electromagnet is spinning inside the area where there are permanent magnets. Now, electromagnets, we use them in lots and lots of things. We use them to record information on audio tapes and videotapes. Not as common anymore. We don't really have the VHS much anymore, and the cassette tapes, but we do use them a lot more in computer hard drives, your credit cards, the black magnetic strip on the back. Your radios have the speakers in them that have the magnets in them. They use electricity for the magnets. We also have telephones, computers, and even doorbells. Now, some of the larger electromagnets are used in junkyards, scrapyards, to pick up cars and move big pieces of metal from one place to another. So we've got an example of that on